You gotta draw the line somewhere, right? So today we're going to talk about respiratory protection, and no, there's not coronavirus information in here, but we can certainly talk about it afterwards if you want. I do a little bit of research on my own, so I do know quite a bit about it. Not too much though, right? So what is the most common workplace exposure route to chemicals? So we know that's going to be inhalation, excuse me. This is your most common type of exposure to chemicals in the workplace, all right? Obviously, very, very common. So this is the kind of thing we're trying to avoid in any situation. And believe it or not, this happens quite a bit. A lot of people don't know what they're exposed to. Maybe they're indifferent, or maybe they willful in some cases. Maybe they just have no idea, right? But in any case, we want to make sure that we know our exposure, so we know how to protect ourselves. And in the case of PPE, what kind of respiratory protection is necessary to go in that area, all right? Some cases it may be an IDLH environment. Anybody know what that is? Immediately dangerous to life and health environment, which is obviously what this environment is, when I'm assuming when they go all the way down to where they need to go. So we're trying to avoid going into places where you're overexposed to certain chemicals unless you have that protection in place. All right, so that's a fail. Okay, so what we're going to talk about today, that first third or so, is going to be a lot of background on the program, on OSHA standards. And then towards the middle here, you'll see a purpose of the program, and then essential written program components, and then the major steps to comply with the standard. Now that's going to be, you'll see step 1, step 2 on the top, and when you see those slides, that's going to be the step, the information you definitely want to take note of, as those are crucial to any program. All right, and then we'll finish off with RIPA, your Respiratory Protection Program Administrator. Respirator considerations, talking about some calculations that you do need to consider for your change out schedule, depending on what kind of chemical you're exposed to. For organic vapors, you would need that. Particulates, a little bit different. So we'll talk about APFs and MUCs, and then we'll finish off with voluntary use and training requirements. All right. So key definitions. I'm not going to talk too deeply about some of these because we've already seen that in previous presentations, but you got your PEL and your AL. Those are going to be your regulatory limits, your OSHA enforceable limits, most commonly seen, all measured with a time-weighted average throughout the day, whatever your exposure is throughout the day, okay? And that's going to be either in parts per million or in milligrams per cubic meter. Now these are going to be concentrations of exposure, all right? Different ways of measuring that. All right, APR, that's your air purifying respirator. It's going to be a respirator that actually filters the air as it comes through the respirator with that cartridge. Now, you'll hear filtering face pieces and 95 face pieces. That face piece itself, it may be made of a material that does filter contaminants out of the air, usually particulates in that case. All right. A SAR, or supplied air respirator, is something that provides positive pressure air to your, whatever it is, your breathing air zone, right? So that could either be in the form of a PAPR, or a powered air purifying respirator, which is this one right here, which means it's actually pulling ambient air into this filter here, this HEPA filter, and pushing positive pressure air, or pressure that's going outwards, into the operator's breathing zone, right? And then you have supplied air from a supplied air line that you have in the facility, which has certain requirements to it. And that is just where you kind of, you quick connect to a valve, an air valve, and you would have air supplied to your breathing zone that way. But that's a little bit more tricky because now you have this tripping hazard as you're walking around trying to do your thing. And then finally, you have your self-contained breathing apparatus, or SCUBA, self-contained underwater breathing apparatus. These are going to be your highest level of protection, as they have essentially their own reserve of air, of normal air inside of that canister, ready to go at all times. All right, and that's a negative pressure or oxygen demand mask, where you have to actually demand the air to come to your face by breathing in and pulling that air from that tank. All right. And then lastly, you have local exhaust ventilation, or LEV. Now this is going to be in the form of any kind of vacuum hose that you have near the work environment. Maybe you have a lot of soldering going on at your place, and you have little ventilation hoods right next to it that you can maneuver as you move around. Or you might have an actual ventilation hood that is continuously pulling air upwards and out of the breathing zone as well. So that is local exhaust ventilation, different from dilution ventilation, which is just your normal room ventilation that you have. Okay. All right, regulatory versus non-regulatory. We talked about PEL and the AL. So you'll see those on the left there, both all in time-weighted average, all right? But what you might not know of is the short-term exposure limit, or the STEL, which is the same thing essentially, just in a 15-minute time span, right? That's what that is measuring. And then ceiling limit is usually, or is the limit that you should not exceed at all, right, at any point in time. And those are going to be regulatory limits. Now, in OSHA's tables, table Z1, Z2, and Z3 will have specific contaminants listed in there and what their permissible exposure limits are, their ALs are, and STELs, and even ceiling limits sometimes. So those will be shown in there, and those are regulated formally, enforceable limits, okay? And then on the other hand, you have ACGIH, or the American Conference on Governmental Industrial Hygienists. These, along with NIOSH's recommended exposure limits, are non-enforceable limits, but again, under that general duty clause, that's going to be something that where OSHA might pull that information from and say, hey, you knew about this other limit, and there's a lot of research to back that up on the side of NIOSH and ACGIH, so this is what you should have been going for. This is what you should have been aiming for, okay? So you should make reasonable attempts any point in time when you're measuring your exposure to base your controls off of what kind of exposure limits there are under ACGIH and NIOSH as well, if you can. Okay, but obviously the minimum is going to be getting below those limits on the OSHA regulatory side. All for the purposes of protecting our workers from inhalation hazards, right? Chemical workplace hazards. All right, that's the main point. And just like here in conservation, we always start with our exposure assessment. What are we exposed to? What do we know of? What kind of chemicals do we know that we were consistently working with in our environment? What are those exposures like? What kind of controls do we have in place? These are the things that you should be asking yourself just up front, just to see, to evaluate your exposure, okay? All right, fact check, which I will do periodically just to kind of take a break from the regulatory talk and all the other information. How many workplace fatalities during resulted from a single exposure to inhalable chemicals in 2017? Take a wild guess.
Under the name?
Conservative guess. No, it's 41. 41, but good guess. All right, and this may seem like a low number compared to fatalities resulting from things like falls, right, or transportation-related injuries. Fatalities. Excuse me. But again, you see right there, that's talking just about a single exposure, just a single instance where somebody walked into an environment that was IDLH and didn't come out of it. So that's just as serious. Even though it's a small number, these are the numbers that could have been avoided. This is a number that could have been avoided, right, in any case. All right, so what is required under Section 134, the Respiratory Protection Program standard, or the Respiratory Protection Standard? Written program, air sampling and determination. This is going to be your exposure monitoring section right there. Administrator assignment. Anybody know what that refers to? That's your RIPA, your Respiratory Protection Program Administrator. That's a formal name for it. But it's not formally mentioned in that part of the standard, but it is referenced in a small entity compliance guide, which we'll talk about in a moment. Then you have respirator maintenance, storage, employee training, ideally where you would let them know about, hey, after so many hours, after so many direct hours of use, or after so many days, to make it easier for them, go ahead and change out those cartridges for some new ones, right? Then we'll talk about surveillance and fit testing a little bit later on, as well as voluntary usage. But as long as you considered all of these things in your written program, you should be all right, right? That is a full and complete respiratory protection program. Step one, very important, as I mentioned before. Of course, you have your hierarchy of controls. But what was actually not mentioned on Casey's hierarchy of controls was those first two steps right there, elimination or substitution. We recently had a case with toluene exposure where they wanted to use a certain coating that had a good amount of toluene in it, which has an exposure limit to it and is quite the respiratory hazard. But in that case, what we did was actually just substitute it out for a coating that could complete the same process or complete the same task, goal that is. And substitute it out for something that was less damaging, right? Or actually did not have any toluene in it. Excuse me. So that's definitely a route you can take. But as you see here, the before and after, this is actually an engineering control for noise. So you can see they encased it in. You got the ventilation hoods there. You got sandblast cabinets that are fully enclosed, and then you have ways to validate your engineering controls. This is actually an example of one for your ventilation systems in any case, whether it's a hood that looks like that or one of those hose hoods that you can kind of manipulate. You can use this smoke tube that actually shows and proves that ventilation is working properly and pulling the air away from your breathing zone or from your worker's breathing zone, right? So that's your first step. And I did consciously put that before the formal step of determining your worker exposure. Why did I do that? Anybody guess why?
More general?
Well, it comes down to if you did your exposure monitoring first, but you just said, okay, we have this chemical, let's monitor, right? And then you found it to be over the exposure limit, and then you have to put all these things in place and implement new ventilation systems and all this kind of stuff, and then validate it after that, so you would sample again. What if you did all your controls, as many controls as you could possibly do and feasibly do before sampling, and do the best you can to do that, including respirators, obviously. And then you monitored. And since you had already put all your stuff in place, it was good. You had enough ventilation and you were below the limits, so now you don't have to monitor again, right? So it kind of saves you time and money in that case, right? And satisfies the intent of that standard. That's the reason why I put this second, all right? So step number 2, determining your worker exposure. Right up there in the right corner, you see the cyclone. That's for respirable particles of crystalline silica, by the way. And so you would typically strap up your employees, and obviously let them know the purpose and why they're being strapped up. They're always asking me on the side of hearing conservation, hey, is this recording my words, right? No, it's not. It's just recording the intensity. It's just recording the intensity. And then same thing in the case of air, you just want to let them know that you're sampling to make sure that we're below the regulatory limits. Step 3, what kind of PPE are you gonna distribute? That's also going to be something you address in your PPE hazard assessments. That's on another note. But here we determine, well, if you're exposed to particulates, you might use an N95 dust mask or filtering face piece. You might want a lot more extra protection in this case from those particulates, and you may want to cover up the eyes as well, so you do a full face. And we'll talk about APFs or assigned protection factors that helps you decide on what kind of PPE you're going to wear. But generally, step 3 is going to be your determine what kind of respirator you're going to divvy out. All right, and that goes out to air purifying, as we see right there, supplied air, whether it's PAPR or a line or a SCBA, right, scuba, oxygen demand. But in any case, they have to be NIOSH approved. You have to make sure that it's NIOSH approved. All right, question. What requirements are there to certify a breathing air facility line if you're going to use a supplied air system? Supplied air respirator. I don't know why there's 2 question marks there. Let's just ignore that.
Someone's got to check that it's actually breathing air.
Right? It has to be grade D breathable air. There are certain requirements that come under that. You're providing the air that's going into their hood, that's all they're breathing. And if that is compromised, that is a problem, right? So in any case, if you're using supplied air, you want to make sure the oxygen content is between 19.5 and 23.5. And then of course all the rest, all these numbers here for concentrations being below those concentrations with hydrocarbons, carbon monoxide, dioxide, and moisture as well, right? On top of that, section or paragraph I-5 of section 134 says that compressor used to supply the breathing air has to prevent entry of contaminated air into the supplied air system. So there are some very, very specific requirements if you're going to be using supplied air respirators for things like overexposures to things like hydrofluoric acid or hydrochloric acid or whatever it is that is significantly corrosive, significantly damaging, with very, very low exposure limits set for a good reason. These are the kinds of things that you'd want to consider if you're going to be using supplied air after that, right? A little bit different with PAPRs, because PAPRs, it just pulls air through that filter and filters it out innately, right? All right, staying on the PPE, step 3, PPE side of things. So there are different types of respirators, and then there are different models, right? You got your half face and your full face, different APFs related to that, and you got hoods and helmets that are usually positive pressure where they're coming through, okay? Step 4, medical evaluations. Okay, medical evaluations are crucial in determining the amount of time that individual, whatever individuals are going to be wearing respirators, tight-fitting respirators, can wear that respirator. How long can they wear that respirator given their health, given their current respiratory health? Because if they wear it too long, it could lead to significant adverse health effects. Okay, so they either fill out a questionnaire or they go see an occupational health doctor. Okay, and this is must be completed for tight-fitting respirators, required or voluntary. Okay, and yes, that does include. Actually, that's going to be a question I'm going to ask you in a second. So no, I'm not going to tell you. This is not to be confused with what we talked about earlier or what Casey talked about earlier in the silica emphasis. So there are different requirements in that medical evaluation for that, specific to that chemical specific standard, right? Where they're looking at certain things based on that type of hazard. For silica, they're also doing spirometry, how fast and how much you can breathe. And then they're also doing X-rays and then blood tests for tuberculosis as well, because those are the kinds of risks that are present when you're dealing with or exposed to silica, right? But generally speaking, for a normal respiratory protection program, that medical evaluation is for the purposes of that respirator. How long can I wear that respirator based on my health, okay? All right, fact check. True or false, medical evaluations of employees can be done in person or online.
In person or no? Both.
Both. True. Judge James says true. Yes. Yes, they can be done. I believe it's 3M's website.
3M has a
3M's website.
And actually make a licensed physician review them.
Yeah.
And then you'll just get notices, yes, no, we'll send them out for the
Yeah. And then based on those answers, maybe there's a red flag in there. Maybe you have some sort of condition that does present a bit of a risk. Then they would ask you to come in, perhaps, and evaluate it a little bit further to maybe determine that.
Got a question over here.
Yes, sir.
So on the prior slide, you had something about a spirometer.
Spirometry, yeah. Yes, sir.
So that tests what, the quality of the air?
No, that's you basically get strapped up to this tube here, and it's measuring how fast and how much you can breathe.
Oh, I see.
It's your lung capacity, right? Yeah. But that's actually in the case of silica emphasis.
With some other specific standards that's a requirement as well.
Right.
Does that give you your VO2 max, or that's a slight?
Not in my house. Not in my house. Yeah, that's false. False. Actually, are required as well for those supplied air respirators. Even if it's positive pressure, you're still enclosed in there, and there still can be a risk of adverse health effects. All right. So yes, absolutely for that as well. All right, step 5, fit testing. Now we all know what fit testing is for, is to make sure that we have the right fit, right? That the way that you don that respirator, is that tight enough, is that seal good enough to prevent the intrusion of contamination into that respirator while you're wearing it, right? And in the case of many different movements, I don't know if anybody here has done a fit test or been part of one before. There are a bunch of different movements that you have to make, that you get the employee to make, going up and down, left to right, head up and down, to see if that respirator fit is solid during that whole process. Okay, so there's a difference between a quantitative and a qualitative fit test. Quantitative is up on the top there, and then qualitative down low, where it's more of a subjective measurement down below, or do you smell it? Do you not smell it? Yes or no? And on the top, they actually hook up a measuring device or measuring tool to actually see how much, what was the concentration that has intruded into that inside of that respirator. Okay. Step 6, cartridge change out schedules. Anybody know about this? Anybody have any of these? All right, so cartridge change out schedule is required for organic vapors. And there are different ways to do that. So we will talk about a few of those, but in the funnest way possible. All right, fact check, true or false. Within OSHA respiratory protection standards, cartridge change out schedules are only required for vapors and not for particulate matter. True. True. Kermit and Christian Bale. Yeah. So it actually mentions explicitly in the standard that change out schedule is required for organic vapors. It doesn't actually, when it starts talking about particulate matter, it doesn't actually say that it's a formal requirement to do so. Okay, so interesting
Why do
fact.
you think that is?
Typically because your particulate matters are going to be more of an outer filter. So if you have the tight-fitting respirator, sometimes you have that little purple cover. That's got that usually probably a 95 or 100 filter on it for the particulates. It's the vapors that actually it'll start to dissolve whatever your filter media.
The moment you open it and expose that OV cartridge, that organic vapor cartridge, even when it's in storage, it's essentially being used. That's why you need to calculate that change out schedule. But for
Concern would be a clogged filter is going to cause a lot more pressure to come in.
Right, so if
along
you
the
have like that
sides.
dust filter on the outside,
Yeah,
that's one of those things where you're teaching them that if you're having a harder time breathing, first of all, check that one to see how clogged it is.
right. And then
if that increases your breathing, you're okay. You just want to watch out for your organic vapor cartridge.
right.
Because that's where usually the media starts to get dissolved.
Yeah, that's a good point. And it comes down to, just like any other PPE, just like JP was talking about before, it comes down just like any PPE, any forklift, any machinery that you're using, you want to do that pre-use inspection. All right, so when you're looking at your particulate filter or your N95, how caked is it? How does it look? Your visual during that visual inspection. So do you determine from there reasonably that you should throw that dust mask away and get another one? Probably, or not, right? So for the case of organic vapor cartridges, where you are working with solvents or whatever it is, that there are 3 valid means of determining that change out schedule. Okay, so there's conducting experimental testing, manufacturer recommendation. Maybe you call them and you ask them specifically about your situation, how often you're working with those organic vapors, what kind of recommendations they would have for that, for how long, and if you can get that in writing, that'd be something that you could probably go off of. And then use of a math model. There are a couple different types of math models. NIOSH also does have a sort of calculator that you can use. So after you've made a measurement, you can input that, frequency, what kind of chemical, all these things, and you put that into the model, and then it kind of shoots out a little, it shoots out a schedule basically, how long those cartridges would last in a single, once you've exposed them to ambient air. Okay, but then there's a fourth method actually. What is that? It's the easiest one of all. Slightly more costly, but easiest one of all. It's called an end of service life indicator. So you either have a method where it would have nothing once you peel it off, and then the stripe would kind of come down, and then once that stripe goes all the way down, that's when you know it's fully saturated and fully used. So you would change out that schedule right there, and you don't need to have anything in writing because that's it. It's innately on the cartridge, and you can use that. Some of them will start a certain color and then totally change another color, but this one is one of those strip examples. So you can use this in place for organic vapor cartridges, or for organic vapor change out schedules.
It's going to be more expensive.
A little bit more expensive, but not like, it deletes a lot of the paperwork and the research, and the part of the training is so much easier because you just tell the people on the floor, hey, like, you see the change every time you do your previous inspection, look at that little strip, and if you see it fully saturated or the color's fully changed, just go ahead and switch it out. And can't really go wrong with that training right there. I mean, it's pretty straightforward. All right. Now moving over to RIPA, Respiratory Protection Program Administrator. Now in the standard, you'll see section or paragraph specifically 134C. It says the program must be administered by a suitably trained program administrator, but it doesn't go so far as to describe what that means, elaborate on what administrator means. But what it does do is reference this document here, OSHA 3384 Small Entity Compliance Guide for Respiratory Protection Program. And in there, it does its best. The government does its best to try to explain what would satisfy the definition of administrator, as you see there. Yeah. So as long as you meet that, you're good to go. But you definitely want to assign, and the whole point of this whole slide here, in the program you have to have a RIPA, right, at your company that oversees the implementation and maintenance of that, sustainability of that program. Okay.
How many is small entity? That's the definition.
Small.
I'm sure that's a number
A formal-
of personnel or
Usually less than 250.
Oh, okay.
Those things where I've seen, you know, like OSHA, things like that, if you go above those numbers, then they consider you much larger.
Okay.
Okay, now moving over to some of the numbers talk here. All right, so an assigned protection factor is a numerical protection level assigned to a respirator that basically gives you an idea of how protective that respirator is. So everybody, all the different types of respirators have their own assigned APF to it. You can see down below, or on the top there, APF of 10 for your half masks. Actually, believe it or not, is the same for an N95 dust mask. It does have a 10 as well. Full face, APF of 50. Your PAPRs here, somewhere in the realm of 100 or so if it's a PAPR. Scuba down here, 10,000. And then your supplied air respirator is going to be 10 to 1,000, usually around 1,000. All right. We can see just how it gives you an idea of how protective those are. Okay. So your maximum use concentration, to skip all this, the verbiage, right? It's basically the maximum amount of protection that a certain respirator will protect you from, all right, given a certain calculation, and that's right here for you. So you use your PEL for whatever contaminant you're exposed to, times the APF, times your assigned protection factor. And from that, you get the maximum concentration that that respirator is going to protect you from, okay? And if you did exceed that number, obviously you'd want to find something a little bit more protective, okay? So quiz for y'all. You have a PEL for nitric acid of 2 parts per million. Very, very low, obviously. You are wearing a full face. What chemicals you have, their SDSs, what the manufacturer recommends, what literature says in the background, all that kind of stuff, so you can determine what's the right form of protection for you. So in a case of voluntary use, say that you measured you measured for silica at your location or any kind of respirable dust in general, because there are actually exposure limits for that as well, just nuisance dust, right? And you found that you were below the exposure limits and below the action limit. And your people just kind of want some extra protection. Maybe they don't like a certain odor or something, and dust masks do tend to help a little bit with odor. So you're like, okay, here you go. Here's a dust mask for you, or this form of a dust mask, N95, NIOSH approved respirator. So in that case, you want to make sure that you give them what's called the Appendix D, the voluntary use form, all right, where they basically sign off saying that they're going to use it properly, they're going to wear it properly, they're going to use it as per manufacturer recommendations, and they understand that it's not required, and that they understand that they're not going to take it into ideal-age environments, right? Things like that. It's very basic. It's a one-page thing that they need to review and sign off on. Okay, but you definitely want to let them know of that. Okay, true or false? This face piece protects the wearer from respiratory hazards.
False. It protects everybody else.
False. Yeah, it protects everybody else. It's just meant to block mist from your sneezes and from your coughs. Yeah. So that's a bit of a problem right there. So people walking around for coronavirus trying to wear in one of these, and you're not protecting yourself from that. You're just, thank you for protecting us from you, but no. Go ahead.
Are those all, I'm assuming, single use for single use?
Yeah.
And then, so is there a time
disposable use?
Yeah, disposable use.
Yeah.
Is there a time limit? Like if somebody wants to wear one for voluntary use, they wear one all day, a full 8-hour shift. They wear it for 4 hours, and then they set it aside, put it in some
container,
a safe sealed place, and then go have lunch and then come back.
Like the normal.
Yeah, it's a disposable mask.
They can use it until it gets full.
Okay.
And until the breathing, breathing has become harder. Yeah, as long as they put it in a bag,
Yep,
put it in a case, you protect it.
And you're good to go. But since there's no formal, calculation that you need to make for that, it's just a matter of training them on the visual inspection. Not just on the visual inspection, but on what kind of signs that you need to be recognizing or looking out for in order to determine that it's probably, used up. Okay. So lastly here, and I put it just in a formal list so that you know that I'm not making this up. This is the list of exact things that you need to train people on when you're talking about respiratory protection your respiratory protection program. All right, so it's a bit of a small print there, but why the respirator is necessary, what the limitations and capabilities of the respirator are, like APFs or APRs, air purifying respirators, not going into IDLH environments with those things, right? Because it's not providing air, it's just filtering the air. And if it's a seriously dangerous environment, like an oxygen deficient environment, then obviously you wouldn't want to take that in there and think that you're going to be okay, right? That's how a lot of these fatalities happen. Excuse me. How to use the respirator effectively, how to inspect, put don and doff that respirator, what the procedures are for maintenance and storage. This is a pretty common deficiency. I'm sure you guys know this one with dust masks or actual half or full face pieces. We often see these just left out on the table, right? Accumulating dust, especially when they're left out with the mask facing upwards, and all the suspended dust is now falling inside of there, and now you have direct exposure. In fact, you probably have ingestion of some sort. So that's definitely a no-no there. So you want to put it in a clean, dry environment. One of my best clients does, they actually put it in a bag in one of those 5-gallon containers, so they take pretty good care of theirs. How to recognize medical signs and symptoms of certain things that you're exposed to, right? Odors, taste, dizziness, nausea, headache, things like that. And the general requirements of this section. So essentially the main components that we talked about, those would be the things that you'd want to talk about with them, right? And these are formally, very explicitly the things that you need to talk about in your trainings, at the very minimum, of course.
Is that 1910 under like 29 CFR?
134, 134, yeah. 134K, that's going to be your training requirement section there. Yeah. It seems like a lot at first, but when you talk about it with them and all these, all the things that are listed here, it really isn't. I mean, it's just, this is all one slide, and this covers a lot of it. Now it comes down to the site-specific stuff and the chemicals that you're exposed, that they're exposed to, that you'd want to maybe elaborate on and talk about some best management practices and practices that they could do.
So that ties into your hazard training too.
Yeah. So in summary, respirators are based on the hazards, the chemical hazards, inhalation hazards that you are exposed to at the workplace. And you really, I can't emphasize this enough, people don't realize how serious this is. In any case, whatever it is, whether you're construction and you're dealing with a bunch of concrete work, right? Or you're in manufacturing settings and you're just, you got some solvents here and there, and maybe it's a hazard, but we'll give them some dust mask, be fine. Wrong dust mask, and maybe you don't even need that because exposure limits for solvents tend to be actually really, really high. That you smell it way before it starts to cause damage. Okay, might be irritating, but exposure limits are high for a reason, or low for a reason. Okay, respiratory protection standard requires certain things. Now, the things that I would emphasize for the sake of the protection of them while they're wearing their respirator is going to be your medical evals. How long can I wear my respirator for? And your fit test. Does it have a good enough seal to truly protect me while I'm working on that chemical or working with that chemical? One thing that wasn't really mentioned in the presentation that I do like to stress is make it a second nature. Anytime you give somebody a respirator that has cartridges, make sure they do their positive pressure and negative pressure checks to make sure the seal is all right. So when you do your negative pressure, you're going to cover your cartridges, the inlets, right where you inhale, and that should kind of press up against your face when you inhale. That shows you got a good seal there. And then when you put your hand on the exhalation valve on the front, that's your positive pressure, because then you blow out, and if that respirator kind of puffs up off your face a little bit, that's a pass on the positive pressure check. All right, but you want to make those two things second nature when you're when you're divvying out and training your employees on using respirators. Okay, and then of course, training is going to be your last summary point there. Okay, any questions?